trigonometric identities from the circle. If we plotted a circle and centered it on the origin of the xy plane, we could draw a line representing the radius from the center to any point on the circle. Let's call that point pxy. If we drew a line from the x-intercept of P to point P, we would have a right triangle with its longest side, the hypotenuse, equal to 1. Our reference angle, bounded by the x-axis and the radius line, would be theta. From the point of view of our reference angle, theta, we can now designate the opposite side, the adjacent side, and the hypotenuse of our right triangle. So from our previous tutorial, we know that the sine of our reference angle theta is the ratio of the opposite side to the hypotenuse, which is equal to 1. If we simplify this equation, we would have the sine of theta equal to the opposite side. Similarly, the cosine of our reference angle theta is the ratio of adjacent side to the hypotenuse of our right triangle. If we simplify this equation, we would have the cosine of theta equal to the adjacent side. So by simply using a circle with a radius of 1, called the unit circle, we have our first two identities. The opposite side of our right triangle is the sine of theta, and the adjacent side is the cosine of theta. Let's take the identities for tangent and cotangent. From our previous video, we know that the tangent of our reference angle, theta, is equal to the ratio of the opposite side to the adjacent side. But we now know that the opposite side is equal to the sine of theta, and that the adjacent side is equal to the cosine of theta. Therefore, the tangent of theta is equal to the sine of theta over the cosine of theta. Similarly, the cotangent of theta is the ratio of the adjacent side to the opposite side. But the adjacent side is equal to the cosine of theta, and the opposite side is equal to sine of theta. Therefore, the cotangent of theta is equal to the cosine of theta over the sine of theta. Notice that we are now able to express the tangent and cotangent of our reference angle in terms of both sine and cosine. Let's take the identities of our last two trigonometric functions, the secant and the cosecant. The identities for the secant and cosecant follow the same pattern. We know that the secant of our reference angle theta is the ratio of the hypotenuse to the adjacent side. Again, we know the adjacent side to be equal to the cosine of theta. Therefore, the secant of theta is equal to 1 over the cosine of theta. And lastly, we know that the cosecant of our reference angle theta is the ratio of the hypotenuse to the opposite side. Therefore, the cosecant of theta is equal to 1 over the sine of theta. There are quite a few more trigonometric identities than what was covered here, and those will be in my next video. Meantime, if you like this video, please give it a thumbs up. Thanks for watching.